Given two set of signals, S1 of t is a sin 2 pi epsilon of t and S2 of t is a cos 2 pi epsilon of t, and also given f0 equal to m by t, where t is the total time period of the signal and m is an integer. So you need to first find out the orthonormal basis. Also you have to plot the signal constellation and compute the probability of error. So we start with the given two signals. First signal is a sin 2 pi epsilon t, second signal is a cos 2 pi epsilon t. So from the given signals itself, you can see one is sine function and another is cos function. Since sines and cos are orthogonal to each other, there will be two basis function, and the first basis function will be root of 2 by t sin 2 pi epsilon t, and the second basis function will be root of 2 by t cos 2 pi epsilon t. It is already clear from the question itself. We can prove it by applying GSO. Okay. So by the Gram-Schmidt orthogonalization procedure, we know the first basis function is defined as first signal divided by root of energy of the first signal. Okay. So first we need to find the energy of the signal. So the energy of the first signal is one of these known as E1. To find the energy of the signal, here we are given a sine wave. We know the power of a sine wave. The power of a sine wave with an amplitude A, the power of the signal will be given as V RMS square by R. Okay, the power equal to V square by R, where V is RMS value. But we know the peak to peak value is same. So it will be the RMS value. RMS value is peak to peak divided by root 2. That is A by root 2 the whole square by R. Consider R equal to 1. So the power of a sine wave or cosine wave is usually given as amplitude square by 2. So just substituting, we will get A square by root 2 square, that is A square by 2. So power of a sine or cosine wave, we already know it is A square by 2. So what we need to find is the energy of the signal. So what is the energy? Energy of the signal is equal to power equal to energy per time. So energy equal to power into time. So power is A square by 2. So A square by 2 into T will be the energy of the signal. So the first basis function is first signal divided by root of energy, that is S1t divided by S1t divided by root of energy. Energy root of energy is A square T by 2 is root. So A root T divided by root 2. Okay, so we know S1 of t was A sin 2 pi epsilon t. So A and E will cancel out. You will be having only root 2 by t into sin 2 pi epsilon t. So that is your first basis function. Now by GSO, how to find out the second basis function? We must define an intermediate function, that is G2 of t. So G2 of t is given as second signal minus coefficient of the second signal along the remaining basis function. Here we have only one basis function, so is 2,1 into 5,1. So we know the GSO procedure. You can refer my previous video on GSO procedure if you have any doubt. Now the first thing is to find out the coefficient S21. So S21 equal to, what is a coefficient S21? It is a component of the second signal along the first basis function. Here it is a S21. S21 is a component of the second signal. Here it is S2. Okay, component of the second signal S2 along the first basis function. So here you have second signal along the first basis function. What is the second signal? Second signal is A cos 2 pi epsilon t. What is the first basis function? We have already noted, root of 2 by t sin 2 pi epsilon t. So you need to solve this integral. Take the constant term outside. Here root 2 by t is constant. You take it outside. Then integrals from 0 to t. You have the term cos A sin B or sin A cos B. Now you can simplify sin A cos B by using the formula half into sin A plus B plus sin A minus B. So A is 2 pi epsilon t, B is again 2 pi epsilon t. So sin A plus B is 4 pi epsilon t and sin A minus B is 0, sin 0 dt. Now we need to do the integral and apply the limit. Okay, do the integral and apply the limit. So we are given the condition, this frequency f0 is m by t, where m is an integer. So when you do the integration and apply the limit from 0 to t, what you get is multiple of 2 pi or multiple of 4 pi, and here you will have 0. That is lower limit is 0, upper limit is t. So when you substitute for the upper limit t, here you get t and f0 is n pi t. So you t will cancel out, you will get a multiple of 4 pi m. So when you take the apply the limit, you will get the value as 0. So S21 will be equal to a into root of 2 by t into 0. Okay, so here the coefficient S21 will be equal to 0. Now we can substitute for S21 here. So what will be G2t? G2t will be equal to S2t minus 0, or will be equal to S2t itself. Now we have the second intermediate function. Now how to find out the second basis function? In order to find out the second basis function, we need to find out the energy of G2t. Is it second basis function is G2t divided by root of energy of G2t. So we need to find out the energy of G2t. G2t is same as S2t. So energy of D2t is same as energy of S2t. We know S2t is A cos 2 pi epsilon t. So for a sine wave or cos wave, we know the power is A square by 2. Okay, power is equal to amplitude square by 2. So energy equal to power into time. So what will be the energy of S2t? A square by 2 into t. Okay, so you can directly substitute the energy of D2t here. So G2t is A cos 2 pi epsilon t. Energy is, root of energy will be A root t by root 2. So root 2 moves to the numerator, root t moves to the denominator, then root of A square, that is A, and here S2t you have A. So A will cancel out, you will be having root of 2 by t cos 2 pi epsilon t. So these are the two basis functions, phi 1 and phi 2. Now you have two basis functions, root of 2 by t sin 2 pi epsilon t and root of 2 by t cos 2 pi epsilon t. Now to plot the signal constellation, you have to represent both the signals S1 and S2 in terms of the basis function phi 1 and phi 2. Okay, so S1 is A cos sin 2 pi epsilon t. So you can represent in terms of phi 1 and phi 2. You know phi 1 is root of 2 by t sin 2 pi epsilon t. So this time 2 pi epsilon t into root of 2 by t, you can write it as phi 1. So remaining is A into, here you have to multiply it with root t by 2, because root 2 by t is required in order to write the term as phi 1. So you have to multiply it with root t by 2. A root t by 2 into phi 1. What about the component of phi 2? Here there is no component of cos, so the phi 2 component will be 0. Similarly, S2t you can represent in terms of phi 1 and phi 2. S2t is A cos 2 pi epsilon t. Cos 2 pi epsilon t is actually the component of phi 2, is it? So you can represent this as phi 2 into root of t by 2. Then whatever is left is A. So A root t by 2 into phi 2 plus, so the phi 1 component will be 0. So this is how you represent the signals. Now we can plot the signal constellation diagram. So first you have the two basis function phi 1 and phi 2. The first signal phi 1 component is A root t by 2, phi 2 component is 0. So this is the signal, first signal S1 of t. Then second signal phi 1 component is 0, phi 1 is 0, and phi 2 component is A root t by 2. So this is the second signal. So plot the two signals on the signal space diagram. Now you have to select a decision boundary. So consider this as the decision boundary, so that this region will represent region 2, where we decide in favor of symbol S2, and this region which is in black corresponding to region 1, where we decide in favor of symbol 1. Okay. Now the decision boundary, this is a line, this line can be represented as x1 equal to x2, that is component along the phi 1 will be equal to component along phi 2. This is a condition where x and y are equal. Okay, so the decision boundary you can represent it as x1 equal to x2. So in any place, right side of the decision boundary you decide in favor of s1 of t. So right side of the decision boundary means x1 is greater than x2, you decide in favor of region 1 or symbol 1. When it lies on the left side of the decision boundary, you decide in favor of symbol S2, that is x1 less than x2, you decide in favor of region 2. So the random variable you can define as y, you can define a new random variable y equal to x1 minus x2, such that when x1 greater than x2, x1 minus x2 will be, that is y will be greater than 0. When x1 is greater than x2, your y will be greater than 0. That is symbol x1t is transmitted. Similarly, when x1 less than x2, y will be less than 0. That is symbol x2t is transmitted. So this is the decision boundary x1 equal to x2. When x1 greater than x2, y, your defined random variable y will be greater than 0. So we decide in favor of region 1 or symbol 1. When x1 is less than x2, your defined random variable y, x1 minus x2 will be less than 0. We decide in favor of region 2 or symbol 2. Now, how to find out the probability of error? So, y is your random variable. You know, y is having a Gaussian PDF. Now, to define the conditional probability density function, we should know what is the mean of y and what is the variance of y. So, first we write down the mean of y. Given a condition, S2 of t was transmitted. That is symbol 2 is transmitted. Consider the symbol 2. Symbol 2 is located over here. Symbol 2 is transmitted. Now, what is the mean of y? Mean of y will be, y we know it is x1 minus x2. So, mean of x1 given symbol S2 is transmitted minus mean of x2 given symbol S2 of t is transmitted. Okay. So, we know what is the mean. Mean will be for a correlated output, you know, the mean will be the coefficients Sij. Mean will be same as the coefficient Sij and variance will be n0 by 2 for the correlated output and the receiver. So, here the correlated output x1. So, the coefficient corresponding to x1 for symbol S2 is 0. So, mean will be 0 minus. Then the correlated output x2. So, the coefficient corresponding to x2 here is a root t by 2. So, it will be 0 minus a root t by 2 or minus a root t by 2. So, that is. Now, the variance. Variance of y is x1 minus x2. So, variance of x1 minus variance of variance of x1 minus x2. So, we know the rule of variance. Variance of a minus b will be equal to variance of a plus variance of b. So, variance of x1 plus variance of x2. So, n0 by 2 plus n0 by 2. So, the variance will be n0. Now, we can write down the conditional probability density function, the conditional PDF of y. So, f y of y given S2 of t is transmitted is 1 by, this is a equation for a Gaussian PDF, that is 1 by root of 4 pi sigma square. Here sigma square is n0. We have sigma square variance is n0. Substitute n0 e raised to minus of x minus mean, where x is, the variable x is y. So, y minus of mean. Mean is minus a root t by 2. Okay. So, minus of minus is plus a root t by 2, the whole square divided by 2 sigma square. Here sigma square variance is n0. Substitute for mean and variance in the Gaussian PDF, you will get this expression. Okay. Now, we need to find out the probability of error. Conditional probability of error given S2 of t was transmitted. So, the error occurs, x2 of t is transmitted. We assume that the x1 should be less than x2. Okay. Or the error occurs when x1 is greater than x2 or y is greater than 0, error occurs. So, we need to find out the area of the PDF from for greater than 0. So, for 0 to infinity. So, substitute for fy of y, take the constant outside, then e raised to a term will be there, and this term, the root of this term, you need to substitute it by the variable z. So, we have e raised to minus of the root of this term, we take it as a variable z and do the remaining substitution. So, you have dy equal to this and y tends to 0 also equal to this, and y tends to infinity, you will get z equal to infinity. This substitute, you will get the standard expression of ERFC, that is 1 by root pi integral from x to infinity e raised to minus z square dz, so that you can write in terms of error function of the lower limit. Okay, so this is for first condition when S2t transmitted error. Similarly, for S1 transmitted error will be the same. So the average probability of error will be the again the same. Thank you.